So there we go. So our magnet is sitting on the inside over there. And now you can see all of these iron filings are making these sort of ring line-ish patterns all around. So what these iron filings are doing is they are showing you what we call magnetic field lines. So a magnetic field is essentially the area in which a magnet can act and how it acts. So if we bring one of our little compasses closer and we place it over there, then you will see it aligns with the magnetic field lines. Let me just put it down so you can see. A little hard, bring it closer. Still a little hard. Okay, lights are not working well. Okay, so they align with the magnetic field lines. So that is how this little magnet works. I am just going to gather all of my iron filings and pour them back into a jar. Okay, so now I just have a slightly smudged paper. So now I'm going to be bringing the stronger magnet here. So there we go. You can already see whatever is left on this piece of paper is already attracted to it. So now if I'm going to shake out my iron filings, you can see that it is already forming a much stronger magnetic field all around here. It looks a little like a pincushion. It's all sticking up. So there we go. Boy, this is so hard to do. Okay. So yeah, and lastly, I'm going to be showing you guys the ring magnet. If I can get the magnet off of this piece of paper. Okay. There we go, iron filings, back in the jar. Okay, so a ring magnet. There we have a ring magnet, and if we pour the iron filings onto it, you will see that it makes a little open area in the center. Let's bring it closer a little. So it has a little open area in the center, and then it starts making the magnetic field lines. Okay. So just pour these back. Take away the paper. Okay. So that was working with iron filings. So the next thing that I want to show you guys from your books is something called an electromagnet and how that works. So let me first start with a nail and a bolt. Okay, so I've got a nail and a bolt, and if I bring them close to each other, you can see they're not sticking together. They're very non-magnetic. Okay, so I've got my bolt over here, and I have a nail. So now I'm going to be making an electromagnet. So for this, you need some kind of power source. So I've got some batteries over here. You need some wire that you wrap in a coil around something else. So here I've got some copper wire wrapped in a coil, and I'm going to be putting it over our iron nail. So then the iron nail is going to be turning into an electromagnet. So let me just connect these over here and over here. Okay, so now this is an electromagnet. I'm not going to be working with it for very long. Why is nothing working? You are connected. Okay, there we go. Great. Wasn't connected properly. So now if I go close to the bolt, you can see that they are sticking together. So our iron nail in the center has now been turned into an electromagnet. And unfortunately, I can't play with this for very long because it is getting remarkably hot. Because it's copper wire that is not insulated. So, fairly hot little copper coil at the moment. We've got our nail, which is back to being completely non-magnetic. And that is how electromagnets work. Okay, so last thing I wanted to show you guys is you can actually magnetize things. So here we've got a pin. It is fairly unmagnetic at the moment. And if we take a magnet, here we have a magnet, and we've got our pin, and you rub it like that using your magnet, then you are busy magnetizing the pin. So now it is actually slightly magnetic. There we go. So we have a slightly magnetic pin. And now you can essentially hang it up using some thread. There we go. Let's get it nice and in the middle. So it's hanging neatly. There we go. So now if we just let it hang, you'll see that it will align itself along the magnetic field. So if I bring it a little closer, you can look here, this is pointing in the same direction that this needle is. So north will be that way. Okay. So there we go. That is pretty much it for today's lesson. I have shown you guys everything you guys need to know about magnetics right now. So let's see, is there any questions? Okay. Something about a tree. I'm assuming that is the iron filings. Okay. So the thing about the train is I'm talking specifically about maglev trains. Maglev stands for magnetic levitation trains. So instead of using train tracks, what they then do is they run the trains on strips of magnets that they place all along where the train tracks are supposed to be. And then the train and the train tracks magnets have opposite polarities so that the train literally sits on a sort of a cushion of air. So this will be the train, this top bit, and this bottom bit will be the track. So the train will literally be sitting on this sort of air cushion, which makes the train run very, very smoothly. So this is a very specific kind of train. You are welcome to go look it up. It is quite fascinating. So there we go, today's lesson. How do you demagnetize something, lastly? So our pin, which was magnetized, you just literally need to drop it a few times, and that will jar the particles on the inside, and it will essentially start demagnetizing it so that when you try and pick something else up, it's demagnetized again. That is why you should never drop your magnets. Yeah. Okay, so thank you guys for coming. Is there any other questions? Okay, so there's one about the maglev trains. It can be a very, very fast train. It depends upon the country. Also upon regulations, normally the trains don't run that fast, but some of the train speed records have been set by maglev trains. So yeah. Is there anything you guys want me to show you again quickly? I've got some iron filings on my desk. Okay, what do you want to see? Okay, so let me show you guys what you guys called the tree again. So we've got our piece of paper, which is now fairly dirty and smudgy, but that's okay. This time I'm going to do it with all of my very strong magnets over here. So there they go underneath the paper. And as we pour out iron filings, they don't even want to pour out because it's that magnetic. They just poured out in one big lump. Yeah. Okay. There we go. So you guys want to see the North Pole to North Pole thing again, so I will show you. Okay. Iron filings put away. So here we have two magnets. So they have opposite poles. We have two of the same poles, and then we have the other poles. So as we move this magnet closer, you'll see that it pushes the like pole away. It doesn't want the same poles to be next to each other. They really don't want to stay together. So, and then we've got opposite poles, north and south, which will attract. So guys, just random hint, opposites attracting only works with magnetism. It doesn't work in real life. Okay. So there we go. Okay. Is there anything else you guys want to see again quickly? Okay. Well then, guys, thank you for coming. I hope you enjoyed it and I didn't bore you to death. So there we go. Wait. I look like a gremlin if I do that. Great. Bye, guys.